For the second part of today's lesson, we're going to look at a function that can have multiple transformations occurring within one equation. So let's just take a look at what the format could look like. F of x equals a b to the x minus h power plus k. That is a standard form of an exponential function with multiple transformations. You can recall from the chart below what each of these mean and how it affects the graph, which we've discussed in previous lessons. Let's take a look at an example. If we have an example, f of x equals 3 to the x power, and h of x equals negative 2 times 3 to the x plus 4 power minus 1. What is all happening to this from the parent function? Well, we can see that our a value is negative 2. So what does that mean, and what does it do? The negative 2 reflects the graph vertically and stretches it by a factor of 2. So in other words, it will take and multiply the y values by negative 2. Negative 1 for the reflection and 2 for the stretch. You can take a look at the exponent here, x plus 4. X plus 4 will translate the graph left 4 units. Recall that the standard form is x minus h. Therefore, it subtracts 4 from the x value. If we had a negative here, it would reflect the graph horizontally, so we would have to multiply the x values by negative 1 and then subtract 4. Remember, order of operations. The negative 1 at the end here is our k. It is telling us that we are translating the graph down 1, which means we will subtract 1 from the y value. So if we take a look at a table, we have a standard form of a table. 3 to the negative 2 power would be 1/9, etc. You know how to get these. So if we take our x value and it says that we need to subtract 4 from the x value, we take our x's and subtract 4 and we get these new x values. Our y values, we reflected it and stretched it and we translated it down. So we need to do, by order of operations, the multiplication first. So 1/9 times negative 2, and then subtract 1. Then we would have 1/3 times negative 2, and then subtract 1. 1 times negative 2, and subtract 1, etc. And you would then get a graph that would look something like this. And you could see various things changed from our original graph. So on all of these, you can look at just the equation, think about the parent function, and take a look at what happened. If you're in graph form, you would be able to look at the graph and figure out, first of all, was there a translation up or down? Was there a reflection? Did it change the direction of the graph? So on all of these, you should be able to figure out what the new equation might be and then what happened. And based on that, we should be able to create tables and create graphs. But the most important thing, we should be able to tell what occurred by just looking at the equation and understanding what each of the components mean to the graph and to the equation.